and today I am back with my new topic, and today I will explain to you about speed and velocity. So first of all, we'll be discussing about velocity. We'll start from velocity and then we'll move to speed, and after that we will try to differentiate between speed and velocity. We'll find out the differences between speed and velocity and why they are called the different terms. Why they are different terms? Because since that will be discussing. So first of all, we'll be discussing your velocity. Okay, so first of all, let me write here velocity. Okay, then the question arises that what is velocity? Okay, it is a very nice question. So velocity we can define as, generally for knowing about speed and velocity, we need to know about the distance and displacement. Okay, distance and displacement. So first of all, before velocity, let me define to you about distance and displacement. Distance and displacement we can define as, just like if I have 2 points, 1 point here A and 1 point here B. If I am going from A to B, okay, through any way, imagine I am going through this way. I am going from A to B through this way. Okay, so here this way we can define as, okay, so this is my distance traveled. We can define it as the distance traveled by me, means AB, from A to the B. So this is my distance traveled. Why does my distance traveled? Because distance traveled by a particle is defined as the total path covered by the particle, okay, at any particular time. Just like we can talk about only simply about the total path covered by the particle. Okay, so here we can define that this is called my distance. If I go from A to B through this way, okay, then will it be called my distance? Of course it will be called, because this is also my total path. If I am going from here, then here I am moving, it is my distance. If I am going from A to B through this way, then this will be called my displacement. Why it will be called my displacement? Because it is not total path. Okay, of course, if I am going through this to this, then it can be also called my distance covered, because total path will be this, but we can call this AB as one more name, that will be called as the displacement. Why it is displacement? Because the shortest path covered by an object is called the displacement. So we can define as, let me write it here again. If I have 2 points A and B, I am going from A to B through this way, then this way is my distance. Okay, this way will be my distance. But if I want the displacement, then the displacement will be again this to this, means the straight line joining the initial point to the final point, because here I am not going directly from the initial point to the final point. Okay, I am going from this way, okay, like a curve, okay, like a semicircle. So but even then, if I am going from A to B, then I can define my displacement as the line joining the initial point to the final point. Means this point will be called my displacement, while this will remain same. This will be the distance. If I am going from here to here, this will be my distance. From here to here, this will be distance. Like this I am going, this will be distance. If like this I am going, this will be also my distance, but always this will remain same. This will be my displacement AB. Directly the line AB will be my displacement, because it can be shortest path from A to B, because there is no shorter path than this. Okay, so no any shorter path than this line will be getting. So the shortest path from A to B is called my displacement. Okay, this is clear. Let us take one more example. I am saying to you, if we have 2 points here A and here B again, I am going from A to B like this. Okay, like a wave tag. I am going A to B like this. Okay, if I am going from A to B like this, so what is my distance? Okay, what is my distance? Okay, so its length will be called my distance. So this is my distance. Okay, this will be called my distance. If I asked you about my displacement will be same. This is my displacement. So displacement is the line joining between the initial point and the final point. So this will be my displacement. If I am going from here to here, then that will be from here to here, that will be distance, but displacement will always always remain same. So this is the difference between distance and displacement. Now we need to remember that it is very interesting point and very important point that distance is always a scalar quantity while the displacement is a vector quantity. Why it is such? Because since we know we cannot tell that distance has any specified direction. No, it does not have any specified direction. Here we can go by this way, so by any way. But displacement has only a specified direction. Displacement has a specified direction. That's why it has a magnitude, and also since we know distance also has magnitude. Okay, so one thing is common between distance and displacement, that is the magnitude. But displacement has a specified direction while distance cannot have a specified direction, and that's why distance is a scalar quantity while displacement is a vector quantity. Okay, so we can write that distance always we can define distance is a scalar quantity. Okay, but displacement is and will always remain as a vector quantity. Why? Because it has a magnitude but as well as a direction. So displacement is a vector quantity and is added like vectors, is added using the triangular law, okay, or the parallelogram law. Okay, so like this displacement we can add if we have two displacement. So we can just like imagine we have two displacement, from here 4 meters, okay, then from here 5 meters. Imagine we have to add those two displacement. First of all, it covers 4 meter displacement, then here 5 meter displacement. What is our total displacement? If this plus this, 4 plus 5, so 9 meters will come, but that is wrong. That will happen on distance. Displacement we can define as, then this will be of course our displacement, then it's the hypotenuse of this triangle we'll find out. Okay, then that will come. Since we know by Pythagoras theorem we can find out its hypotenuse, or we can also call, in physics we call it the triangular rule of vector addition. We have already studied the vectors, so here we can find out the displacement. So this we know about distance and displacement both, since we know both dimensions are L. Okay, and on m and t the power is 0, on L the power is 1, and since we know both have the same unit, SI unit, that is meter, other units are also kilometers. So like this. Now let me erase this. Okay, then this I have erased, and here now what we have to do, we have to discuss over velocity. Question arises, what is velocity? Okay, nice question. Velocity we can define as, imagine I am going from one point A to another point B. I am going, then here I am going from A to B through this path. Imagine, then is this path my displacement? Okay, of course it is my displacement. But if I asked you, is it my distance? Of course it is my distance. Why? Because it is motion in 1D, means motion in one dimension. For motion in one dimension, always distance equals to displacement for motion in one dimension. So, and for motion in 2 dimensions, 3 dimensions, distance is always greater than displacement, because distance is total path, displacement is shortest path. So here, this is my displacement. Imagine I am writing this displacement as S. Generally, displacement can be written, generally in many books it writes X, many books S, and many books D. So S I am writing here. If this displacement covered by me is S, while going from A to B, okay, in T time, in T seconds, okay, in T seconds I am going from A to B by covering a displacement S, then I can define that the velocity of mine is, velocity is a vector quantity. Why? Okay, why it is vector? We'll discuss over it. First of all, vector V we can define as, okay, vector S divided by D. Sorry, here vector let me apply, arrow let me apply, because here this displacement we are taking. Remember, not the distance, displacement we are taking. So vector V we can define as vector S divided by T. Now here question arises, this I gave formula. What actually it it. What actually is velocity? So first of all, velocity we can define as, so the ratio of displacement to the time is called the velocity. Ratio of displacement to the time. Its unit also we can easily get meters per second. Ratio of displacement meter, unit of displacement is meter, unit of time is second, so its ratio will do meter per second. Now, so the ratio of the displacement to the time is called the our velocity. Now question arises, what is velocity? Okay, scalar or vector? Of course it is vector, because velocity always is in one direction, in a specified direction, because since it depends upon the displacement. Displacement is a vector because it is in a specified direction. Then the velocity is also a vector quantity that is present in a specified direction. So this can be also added by using the triangular rule or the parallelogram method. Okay, so this is the formula. So vector v, okay, since we know why I put here arrow, because it is a vector quantity, so vector v equals to vector s divided by t. So since we know time is a scalar quantity, so here arrow I haven't put, and displacement is vector, so arrow I have just put. This we got. Now this is a very important formula. Okay, it will be very useful formula to us to solve the questions, so based on velocity. So in many questions in JEE mains also, many questions such it asks in JEE mains advanced, they directly using this formula not, but in many methods whichever will be solving, so in many methods this formula will be used in any particular step. So this is very important formula for us to learn. It is very important. Okay, then now let us move to the kinds of velocity. Okay, so first of all let me raise this. Okay, then kinds of velocity, we can denote velocity in two kinds. The first kind is, okay, velocity we can just like differentiate in two types. First is average and second is instantaneous. Okay, first is average and second is instantaneous. So we have, what is average velocity? This is our question, and it's very nice question. Average velocity we can define as the ratio of total displacement to the total time taken. Just like if I am giving you example, I have 2 points A and B. So what total displacement I will be covering from A to B? Total displacement, that okay, if I am covering the total displacement S, vector S, in t seconds, then I can define my average velocity. Okay, average velocity. So I can define my average velocity is such. Okay, we can write average velocity in this form. Okay, this will represent the average velocity. So I can write my average velocity as the S, vector S divided by T. Okay, average velocity is equals to vector S divided by T. So what is the difference between then the average velocity and velocity? Why just like then why have we specified here average velocity? It is the same, of course, but it is not the same. Velocity can be at a total time interval and can be at an instant. Okay, just like here we can see in many cases that velocity can be at just like if I am traveling from this to this hole, then I am traveling in a total time interval. Okay, so average velocity is the average of all the velocities, because velocity may also change. Just like imagine from here 2 meters per second I am going, up to here I am reaching, then 5 meters per second, 7 meters per second, like this I am going. So velocity is changing. Then the average of all the velocities which I will be taking, that will be my average velocity. Okay, it's understood. While velocity can be also average and can be also at any instant, that is instantaneous. So average velocity we can write as the total distance. Okay, remember, not only the distance, total distance in a complete journey divided by total time interval. This is average velocity. Now we can define instantaneous velocity as at a particular instant. Imagine I am going from A, okay, to B. I am going from point A to B. Okay, so in this, imagine I am going from anywhere to anywhere. Imagine I am going from UP to Patna, and in the midway I am going, imagine I am going with bike, and my friend sitting on the same bike with me is asking to us that what is my speed at this time, or he is asking what is my velocity at this time, and I am telling to him, okay, and my velocity is anything, 2 meter per second, 3 meter per second, okay, 100 meter per second, anything it may be. So I am telling him my velocity. So at that particular instant, I'm telling, imagine I am at this point at that time. So at this point, what my velocity is, that velocity I'm telling, not the average. Means imagine I have started from here, then from here to here, what average velocity is, the average of all the velocity. Here 2 meter per second is, here 3, here 4, here 5. Imagine such as, then I will be not taking the average of all velocities. I will be not giving the total distance displacement covered divided by total time taken. I will be not giving that to him, to my friend. I will tell the same velocity which is at that instant. So at that instant, now question arises, what is the formula for that? So here only what we have to do, just like what we write to velocity, just like velocity. Okay, here vector we can write as, since we know s by t means the displacement divided by time. This we write. Imagine I am writing here delta s by delta t. Why I am writing such? Of course, then here question to this answer is, because I am writing delta s divided by delta t, because s, if s is my total displacement, means from here to here, this whole displacement, the total time interval, the time interval from where I am reaching from point A up to this point, that is t. So here I am writing delta s divided by delta t, means at this particular instant what my displacement will be, that I am writing. Here, since we know that delta t extends to 0, delta t extends to 0. Why it is such? Because at particular instant the t will become very small. Okay, delta t will become very small and it will come nearly equals to 0. So here limit we can apply. Okay, so limit I will be applying here. So I can write as vector v equals to limit delta t extends to 0, delta s by delta t. This when we'll do, so when it will become, it will nearly come to 0, then since we know it will become very small, for very small we write it as dt. So this will also become very small, this will write as ds, so which is equals to ds by dt. So implies that the vector v equals to ds by dt. This we got, of course. Now finally, then this is our main equation. This equation we got means the differentiation of s with respect to t. If s is a function of t, means the differentiation of s with respect to t. Then we can define as the instantaneous velocity or at a particular instant. Okay, is, okay, it can be defined as the differentiation of s with respect to t. This we got. This is the instantaneous velocity. Now velocity is ended. Now we'll come to speed. What is now, since we know velocity already we have studied, let us come to the speed. Okay, then now speed. So here let me write here speed. Then what is the speed? Since we know that velocity I have told as the ratio of displacement with time. Imagine I am going from A, from point A, here is A and here is B. Imagine I am going through any path, I am covering, okay, I am going from here. Through this path I am going from point A to point B. This is my distance, of course this is my distance. If I make a straight line, this is my displacement, of course this is my displacement. I am going through A, from A to B, okay, through this path. Then this is my distance, of course. If this is my distance, I am covering the s distance in, okay, in t seconds, then I can define my speed means v as s divided by t. It is s divided by t. Now you will say that to velocity also I defined same thing, s by t. Now to this also I am defining same thing. Then what remains the difference between them? But note here that s is the distance. S is the distance. It is not displacement. If it would be displacement, I would apply arrow here. Why? Because displacement is a vector quantity. Distance is a scalar. I am not applying arrow. So here speed is also a scalar quantity because it does not, has no specified direction. It does not have any specified direction. So here no arrow I am applying over speed. This we got, of course. Now here we can see speed is also of two kinds, average and, okay, that is also average and instant. instantaneous. Before that, let me tell you that since we know for velocity that the unit SI unit is meter per second, for speed also it is same. Why? Distance unit is meter, time unit is second, meter per second. This we got using the formula. So this formula we have, now this we got. So of course V equals to S divided by T. Arrow I didn't apply because those all quantities are scalar quantity. Okay, this we got. Now of course, now only what I have to do, I have to define to you the means about whether what is the kind of speed. Okay, so first of all, first kind is same. So first of all it is average. Okay, as velocity it was. Second is also instantaneous. Okay, so first of all this is average, this is instantaneous. Now only what I have to do, average velocity, sorry, speed we can define as, we can define average speed as the magnitude of average velocity. Okay, magnitude of average velocity, and as such we can define, or average is, okay, so average speed we can define if I am writing this as VAV, if I am writing VAV, okay, this I am writing, or if I am writing this as VAV I can write, or if I also want then such I can write speed, letter average symbol such, then this I can write as the total. To first of all, if total distance covered is S and total time taken is T, then S by T. If here, remember here also total distance covered, not total displacement covered. This is the total distance covered divided by total time taken. Unit is same, meters per second. Dimension, since we know dimensions of okay, distance is L, time is T, so dimensions of speed is LT per minus 1, and for velocity also it is LT per minus 1. So total distance by total total distance covered by total time taken is again average velocity, sorry, speed. Now here this is very simple. Okay, again we got, let me tell you very interesting point related to speed. Speed we can define as, speed is equals to the magnitude of velocity. Speed is the magnitude of velocity, or we can write that V is equals to mod of vector B, V. So if we take the mod of vector V, so the vector of arrow will be removed, because only magnitude we are taking of any vector. Magnitude of any vector is a scalar, hence speed is also a scalar. So here this we got, of course. So this is very important thing. So here we can write, so this also we can write that the average speed, okay, average speed equals to the magnitude of average velocity. That we can write. Instantaneous velocity is also, sorry, speed is also very simple. Only what we have to do, same thing we'll be doing, that speed, since we know speed at any particular instant, okay, speed at any particular instant, it is same ds divided by dt. So speed we can define, okay, instantaneous speed is ds divided by dt. How we had got ds divided by dt, okay, in that, in velocity same process is only here. It is distance, means the okay, differentiation of distance to the time interval, okay, or we can call the differentiation of distance with respect to the time is called the instantaneous speed, means the speed at any particular instant. This we got, of course. Now this, now about speed we have done, velocity we have done. Now main topic in this video is, main point in this video is the difference between speed and velocity. So first of all, let me erase this. Okay, then difference between speed and velocity. First of all, okay, let me make a line here. Here let me write speed and here velocity. Okay, so first of all, difference between speed and velocity. First of all, main difference is that speed we define as, speed is equals to what? Speed is equals to the displacement divided by what? Divided by time. Speed is equals to displacement divided by time, while velocity is, okay, sorry, this is distance, okay, speed is distance by time. Distance by time. Speed is distance by time, while velocity is the displacement by time. Okay, velocity is displacement divided by time. So speed depends upon the distance covered and the time, while velocity, okay, depends upon the displacement covered and the time. Next is speed is a scalar quantity. Speed is a scalar quantity, while velocity is a vector quantity. Why it is? Okay, so since we already know, because it has a only magnitude and it has a magnitude as well as a direction. So main differences are those, since we already know that the two main differences between speed and velocity are those, that is speed is a scalar, velocity is a vector. And so already speed, and since we know speed is always positive, speed is always positive, while velocity can be negative. Velocity can be negative. So, and since we already know speed is never equals to 0. Speed is never equals to 0, while the velocity is equals to 0. How? So of course we can know that, imagine we are going from any point, 2 points we have, from here to here we are going A to B. Okay, A to B. Imagine first we are going from A to B, then again we are returning from B to A. So here, since we know velocity depends upon the position, so here again same point we are, so of course then the displacement covered is 0 and velocity will become 0 by time, that is 0. While the speed, what will be speed? Since we know distance is 2 times of the, if this is D, then for what distance we are getting? 2D, D plus D, 2D. So finally what speed will get? 2D divided by 2 divided by T, that is the time interval. So speed is never equals to 0, while velocity can be equals to 0. So main differences are those. So since we know it depends upon the distance and it depends upon the displacement, this is scalar, this is vector, this is always positive, this can be negative also, because if negative, how? Imagine first of all from A to B, then returning to A, and then in this direction negative it becomes, of course negative it becomes, because in negative direction it is going, then displacement is negative. This is 0, but this is never 0. This we got. So this was my today's topic based on speed and velocity and the main differences between speed and velocity. So this was my today's topic. Thank you.